Unit 21, Pipe Welding. A pipe welding system is an assembly of pipe or tube, thin-walled pipe, sections with the fittings, valves, joints, etc., necessary to direct and control fluids in either liquid or gaseous form. As shown in Figure 21-1, welding is one of the many methods used to fabricate a piping system. 3 welds, 2 welds. Pipe size is determined by its nominal inside diameter measurement, which differs slightly from the actual inside diameter. Pipe is also specified by pipe schedule. A pipe schedule number indicates the wall thickness of the pipe as listed in the schedule by nominal diameter. Generally, as the schedule number increases, the wall thickness for a nominal inside diameter increases. Look at 2-inch diameter Schedule 10 pipe in Figure 21-2. The wall thickness is 0.109. Now look at 2-inch diameter Schedule 40. Notice the wall thickness is 0.154. Tube, tube is measured by its outside diameter. Tubes are available in almost any wall thickness. However, the wall thickness is generally less than the wall thickness of pipe with the same outside diameter. Note, the welding of critical or high pressure pipe systems where weld defects could be costly and life-threatening requires the skill of specifically trained and qualified welders. Often national or local codes of construction require the welder to pass a qualification test before welding on any pipe or fitting. Pipe drawings. Pipe drawings show the assembly of a pipe system. Figure 21-3 gives an example. Pipe drawings are made in either double line or single line drawings. Compare the two types in Figure 21-4. Double line pipe drawings are used to make scale layouts where dimensional accuracy is important. Pipe and fittings are drawn to exact scale. Single line drawings are diagrammatic. A pipe drawing shows how to construct a pipe system. Computer-aided design process prepared this pipe drawing. As you learn, special symbols are used to denote components. Most pipe layouts are single-line drawings in isometric or oblique views because orthographic projection views or three-sided drawings of piping are difficult to read. An isometric view shows an object as it is with lines showing width, length, and depth drawn full size or in proportional scale. An oblique view shows the front view in true shape and size, and the other views similar to isometric drawings. Fittings are normally shown by standard conventional symbols, Figure 20-5. However, some firms have developed their own series of pipe symbols that may vary slightly from the American National Standards Institute ANSI symbols. Dimensions on piping drawings give the location of components. They are made to the center lines of the pipes and fittings. A parts list or fabrication schedule may be found on the drawing or an attached sheet. One example is shown in Figure 20-6. Equipment installations that utilize piping are sometimes shown as pictorial drawings, such as isometric or oblique. Standard welding symbols will be used. The type of pipe and sizes are indicated. Single line pipe drawing. Piping Piping drawings may be presented as either double line or single line prints. Double line prints are used to make scale layouts where dimensional accuracy is important. Single line drawings are diagrammatic or grammatic in nature. Excuse me. Note a few of the many pipe symbols. While many companies use ANSI symbols, some large companies have desired their own symbols. Designed. A parts list or fabrication schedule is commonly included on a pipe drawing. However, it is too lengthy to fit into the drawing. It is presented on a second sheet. Reference to this sheet will be made on the pipe drawing. This is a pictorial of a commercial refrigerating system with roof-mounted air-cooled condensers. There are 6 refrigerant lines. Equipment installations using piping and tubing may be shown in this manner.